Look at this example. Yeah, please read it. Let me change the notations. Let me say it is a B, and that is a A1 and A2. Using the notations in the base rule. So now, I want to make the Venn diagram. Sample space, S. How many groups? 2 groups, 2 A's. Here is a A1, A2. Who are in A1? Who does not have the lung disease? And who is in A2? Patients. So we just separate 2 groups. The normal person, A1, patient, A2. It's good, right? And I told you we need 1B. What is a B? Who are smoking. It is a B. Can you understand the example? Can you make the Venn diagram? Let me ask you, who is here? Who are they? Non-smoker, because it's out of B, non-smoker, and does not have any lung disease. It's most of you, most of us, right? Who is there? Smoker and, lung disease. Who is there? Non-smoker. I'm so sorry, but who has a lung disease? It's possible, right? Yeah. How about this here? I smoke. Fortunately, I don't have a lung disease yet. So can you understand case by case? Is it good, right? Okay. Let me ask you the probabilities. How much was the probability of A1 given? What was that? The ratio, the percentages, who does not have the lung disease. Just a second. Who was this? 7%. It is the percentages who has the lung disease. So actually the 7% is the probability of A2. Am I correct? That is a 0.02. Then what is the A1? What is the probability of A1? It is not given, but you can take the probability A1. How much? How much did you say? 0.93. How did you get 0.93? 1 minus 0.07. You know, at the beginning, we separate the sample space exactly 2 groups, A1 and A2. So when I merge A1 and A2, non-lung disease, lung disease, it must be 100%, right? So even though 0.93 was not given, but we can figure out the other one from 7%. 1 minus 0.07. Okay, then how about this one? 90%. What is a 90%? Of those who have lung disease, 90% of them smokers. It looks like conditional probability, isn't it? So now I can state who has lung disease. Among the patients, the ratio, the percentages of the smokers, it was 90%, 0.9. How about the other one? I mean, this one. 25.3%. Who is this? Same patients is given. Not B, non-smoker. Just a second. Something wrong? Oh, I'm sorry. I was wrong. Of those who does not have the lung disease. So I have to correct given A1. Then the conditional probability of B, smokers. Still, yet, I don't have the lung disease, but 25.3% of them, they are smoking. It's good? 0.253. So we had probability of A1, probability of A2, which was given. And also, we have a conditional probability of B given A2 given. And probability of B given A1 was given. And we made a Venn diagram. Also, we can make the tree, probability tree. So let me try to make the probability tree. Let me split two groups, A1, A2. Who was the A1 in? In A1, patient or non-patient? Non-patient, A1. A2, lung disease, patient. Good? Next one, B. Smoke. Not B, non-smoker. Among who has a lung disease? They can smoke? Might not. Does it make sense? Right? Can you give me the chance? A1? How much was the probability A1? It's non-patient. What was the ratio? Non-patient. 0.93. From 1 minus 0.07. The other one, A2, was given 0.07, 7%. Do you remember how much was the sum? It was 100%. So that is the reason why we took 0.93 from 100% minus 7%, 93. What was the name of the rule? 1 minus something. Inside, outside, outside, inside. Complementation rule. Do you remember that? Whatever. 100% minus 7% will be the other one. Can you tell me this one? Which is the conditional probability of B given A1. How much was that? B given A1. Smoking among the non-patients. It was given 0.253. Yes, here is a 0.253. Which one was the 0.90? Which one was the 90%? This one was the 90%. Patients, among the patients, 90% of patients, they are smoking. Okay, now, can you tell me this one?
0.747.
Say again?
747.
0.747. I'm sorry. What did you say?
747.
747. Thank you. How did you get 0.747?
Subtracted 0.253 from 1.
Why?
Because that has to
Because we knew add the two probabilities was 100% again. Then can you take this one also?
1.
Same idea. It was 90%. The other one will be 10%, 0.1. Let me complete the probability tree. You know, before we take this one and take that one by the general multiplication rule. We took the probability there. So now we have to do 0.93 times I don't have a space. 253. And the next one, 0.93 times 0.747. It's always by the general multiplication rule. And the next one is going down, and this one will be 0.07 times 0.90, and the last one will be 0.07 times is 0.10. Can you take the multiplication for me? How much will be the first one?
0.235.
0.235. Second one?
0.695.
695. Next?
0.063.
063. Next?
0.007.
007. Finally, take the sum. Try it. Don't say 100%. Yeah, we knew it. It must be 100%. But please make sure. Please sum up the 4 possible probabilities. Get one? Thank you. Again, the first one, 100%, 100%, 100%, and finally, the last one must be 100%. Okay? So, for the base rule, we can make the Venn diagram. Yeah, basically, we can make the Venn diagram. It's like this. I mean, this one is A1, A2, and here is a B. And also, we can make the probability tree. Okay. I do not finish base rule today, but we are going to finish chapter 4 tomorrow. So we are going to discuss the base rule is tomorrow. But tomorrow will be the worst day. Yeah, it is the most difficult one. But at least you have to understand how can we make the Venn diagram, how can we make the tree for the base rule. For them, clearly you have to understand what is the example, what is the experiment. Now, okay, I wanna take another conditional probability. Let me see. What I need. Just a second. What I need. Let me see. A2 given B. I need A2 given B. What is that? You have to understand what does that mean. How can we interpret A2 given B? We had B given A2. It was given with the probability 0.9. Okay, let me try to interpret the given probability B given A2. What is this? B given A2. A2 was given. Who was the A2? It's a small. Okay, just a second. Let me clean up. It was the A2 who has the lung disease. What was the B? Who is smoking. Please remember, what is the B? What is the A2? Okay, let me go back to this one. B given A2. It means among the patients, A2 is given among the patients. What is the ratio? What is the percentages? They are smoking. 90%. Man, why not? Yeah, don't smoke. It is not good for you. Right? Among the patients, the 90% of patients, they are smoking. Do you understand? But now, what's this one then? Based on the smokers. Among the smokers, the chance who has the lung disease. It's a totally different. The previous one, B given A2 among the patients. But the A2 given B among the smokers. Okay, let me ask you. Now, both of them is the probabilities. The chance ratio. Which one is easier to get? Is it collect the data, patients, or collect the data for smokers? Which one is easier? To collect patients, to collect smokers. Where is the patients? In hospitals, yes. You know, even though we visit the doctor's office, a specialist for the lung disease. Have you ever been to the doctor's office for the first time? The nurse gave us many documents. Almost an hour, we have to fill up. Do you smoke? Do you drink? Your parents' history? Is mother's side, father's side? They had records. So many histories. It is easy. It is easy to collect the patient's history, right? So I can say this probability B given A2 among the patients to get the probability 90%. It is much easier than the other one. For the other one, A2 given B, we have to look for the smokers. Where is the smokers? Where? Don't smoke on campus. Where we can see the smokers? We need more data. It's many smokers, right? Where can you see the many smokers? No? You don't know? Everywhere?
Yeah. I mean, there's no way.
Have you ever visited the casino?
No.
No?
No.
Never ever?
Never.
Are you sure?
I promise.
The bar, yes, bar. There are so many smokers. Casino. Yes, why not? Almost everybody are smoking. Yeah. So when you visit the casino, because we need the smokers for the second probability, given B among the smokers. When you visit the casino, when you visit the bar, they are crazy, they lose money and drunken. What do I need? I need the probability if they have the lung disease. At casino, at bar, when I ask them, excuse me, sir, do you have a lung disease? Oh my God, don't do that. It is not easy. It is not easy. It is not easy to get the second probability. I mean this one. But don't worry about that. We have base rule. What did I say? This probability, B given A2, is getting easier from the doctor's office. But what do I need? This one. Think about that. I'm smoking. I'm not smoking, but if I'm smoker, every single time I'm smoking, I concerned, oh, if I have any lung disease, lung cancer, oh my God, I have a beautiful wife and 2 kids. Yeah, my daughter is going to college this semester. Oh my God, yeah. Always. Not even smokers, researchers, they want to know the probability, this one. A2 given B. But it is not easy. Please don't go casino. Please don't go bar, right? That is not a good idea. It's harder. It is harder to get the probability. But now we have a base rule, I told you. Using the base rule, we can switch conditional probability. Okay? So, please remember, we need the marginal probability of A1. How much was that? 0.93. Please copy, it's somewhere. Please keep the probabilities. We need them. And the other probability, the other marginal probability of A2. How much was that? 0.07. Yeah, which was given, 0.07. Okay, thank you. Take a picture. That is a good idea. And we had this one, B given A2, which was 90%. And B given A1, which was 0.253. And now, I ask you, what is the probability of A2 given B? Okay, let me go to the clean page. Okay, here is a good page. Okay, let me do here. What do we need? Probability A2 given B. Please remind what was the base rule. I can give you the base rule. The base rule said it is the same as the probability of A2 times probability of B given A2. And denominator, simply the denominator was the probability of B. But by the rule of the total probability, the probability of B, just the smokers, was summation probability of AI times the probability of B given AI. I'm genius. I can remember any formulas. No, I'm not. Look at this. Here's a A, the single A, 2. Here's the AI in general, because we are going to take the sum. B given DA, 2. B given AI. Again, we have to take the sum. It's the same format. The first one, marginal probability. The second one, conditional probability. But in the denominator, we have to take the sum. Nothing. It is nothing. Exactly, it was the base rule. Okay, let me do it. I need more space. How much was the A2? How much was the probability of A2? A2 was the patient. What percentages? Patients. Just the patients. Come on, please give me. I changed the page. 0.07. 0.07, thank you. And now, what is the percentages? They are smoking. I mean, the patients are smoking. I remember 90%. It's 0.9. Good. Now, we take another multiplications for patients and non-patients. Right? You know, it must be probability of A1 times the probability of B given A1, add summation, probability of B, A2 times probability of B given A2. Right? It's a case by case. We have to take the multiplication for each and then take the summation. So what is the A1? How much was the probability of A1? Non-patients. It was not given, but we figured out it was 1 minus 0.07, so it was 0.93. What is the percentages? What was the percentages? They, non-patients, are smoking. It was 3 decimals, right? Point, help. 253? 252? Okay, thank you. 2, 5, and 2. Add. And the second one is the same as this one. Yeah. So 0.07 times is 0.9. I told you it is the most difficult one. Give me this one. 0.07 times 0.9, please. Say again?
0.063.
Then this one must be same as 0.063, the second term. So let me plug the second one here, 0.063. And let me take the other one, this one please. 0.93 times 0.25 and 2. 0.235. Okay, good. Now, just to keep it, 0.063. And can you take the summation of these two?
0.3.
Just a 0.3?
So it rounds to?
I need the 3 decimals.
0.298.
298.
Yes.
Finally, it's almost done. Take the ratio.
0.211.
What's this? The chance you will get a lung disease when you are smoking. 21%. It is smaller than I expected. Probably the given probabilities is not a real one. Yeah. Probably the probability A2 given B is much bigger than 20%. Yeah. Don't smoke. It is not only 20%, right? But based on the given probability, yes, it is the 21.1%. What? That is your chance you will get lung disease later when you are smoking. Isn't it fantastic? See, again, we use the conditional probability B given A to get what? A given B. Let me give a hint. Let me give a tip. In the homework, exam, always you will be asked to get the left one. Probability, any A given B. Always the right one, conditional probability of B given A will be given. Be smart. Always we need the left one from the right. Always you will be asked to get the left one. Always you have the right one. Okay? So when you are doing the homework, exam, you have to read the problem carefully. And also remember, we are going to have many A's and one B. Then you have to figure out who are A's, who is B. And remember, you will be asked to get a probability, any A, one of the A's, given B from the right.